Hello, my name is Juan Lenger Caballero. I am from Boston, Massachusetts, and the name of my project is Helping Hand, a soft robotics glove project. As you can see, this is a project that I designed to help people with motor deficiencies in the hand, such as those who have suffered strokes, Parkinson's disease, or other conditions that make movement in their hand difficult, to help move their hand better. My thesis is that my idea for a project is to design and build a glove that can help people with motor deficiencies in the hand, as I just said, and I think it would be beneficial to people who have suffered strokes, Parkinson's disease, or other disabilities that make movement in their hands difficult. Um, I used this book called Ending Parkinson's Disease, A Prescription for Action by Ray Dorsey, Todd Shear, Michael Suokun, and Bastian R. Bloem, who used the statistics saying that in the past 25 years, the number of people with Parkinson's has doubled from 3 million to over 6 million. And as a person who has experienced this firsthand with my father, who has Parkinson's disease and currently lives in a nursing home, I have experienced this very firsthand, and I would like to help people and others who have these problems all over the world, with motor deficiencies in their hands and other problems like that, to help move their hand better. How I would do this is I would make a glove that would inflate with air pressure on the back of the fingers from an air pump on the top side of the wrist, but also a function where strings attached to the fingertips would go down to the glove, held by little sleeves, and would wrap around a motor wheel on the a motor slash wheel on the bottom of the underside of the wrist that can twist and pull the strings, which would help to bend the fingers for people who have trouble with motion such as that. This is just a person who has trouble moving their hand, and as I said earlier, millions of people all over the world have this problem, and I would really like to try to help people with this issue that is very prevalent and I have seen firsthand. And yeah. Here, my precedents. There have been other people who have done, or other companies that have done this kind of project, like the Weiss Institute at Harvard University has done a glove with like this on the top right, where basically they did like a inflation mechanism, but also mine could be a cheaper alternative or a different kind of less expensive glove with different materials. They could also utilize the string mechanisms that go down on the palm of the hand, and yeah. Here's my storyboard for the project. As you can see, it's someone with a shaky hand trying to grasp a mug, but they cannot. And now with the glove, that they can pull the fingers toward them, and then also have the back inflated mechanism. They can hold the mug all right. As you can see, kind of cut off, but you can see what it's trying to convey. Here is my sketch for the front, the palm section of it, with the strings attached to the fingertips and then wrapped under some tape, or some like sleeves on the fingers, and then going down to a mechanism on the wrist, probably like a look kind of like a watch with a wheel and a motor that would pull them and then be able to stretch or no pull the fingers towards the palm. Here are some iterations of it. As you can see, here's my some of my first prototypes. And I mean, I haven't actually finished the project, but I mean, in engineering, really nothing is ever finished. You just need to find ways to keep improving. So yeah, as you can see here is a yellow rubber glove that I use as my prototype. I attached tape and duct tape around to it and had the strings going on the fingertips going down, and then had the multiple sleeves on each finger and on the bottom of the wrist. Also, here is the inflatable mechanism that you can see in some GIFs. The different iterations of the finger bending mechanism as it got updated over time, because I did many different iterations of it. And as you can see, this one doesn't inflate too much, but then as I modified it a bit, this one inflates much more and it bends forward even further. Here are some demonstrations. As you can see in this video, it did not work as well as I would have liked it to, because it was a quick video, a short little video. But as you can see in this image, this was just me pulling on the strings because I never finished the motor part, or I never completed the motor. I used a motor, but I'll see that in a future slide. But I feel like I could improve it with other resources and materials that could make it more easy to and stronger to pull the strings down. Because as you can see, the middle finger and the ring finger did not come down as much, but in here they did pretty well. And you can see it's compared to my this is just the palm section of the project compared to my sketch. Then here are some silicone experiments that actually tried to use for the backside of the hand, where I would have had some air tubes that would inflate and put on and would inflate the back and push on the back of the fingers to push them forward. I used silicone molding material called Dragon Skin 10 to attempt to one make a glove that with silicone material, and that didn't exactly work out. So I could have like a more bendable material, but that didn't really work out. And two, use it as a passageway to combine all the tubes from an air source to separate into different tubes from the 5-finger bending mechanisms on the back of each finger, right? And on the next slide. This didn't exactly work out too well because I got this Dragon Skin 10 material that was recommended me by kind of a mentor, but we got the wrong, or not the wrong one, but it was one that dried much faster, so I didn't really get to use it to the full capability without it drying. But I did try to use it so I could build or make a silicone like sleeve and then have it inflate. Here are the silicone experiments continued. As you can see, here's what the mechanism silicone air passageway split off would have looked like right here, but it didn't exactly pan out that way. And here's the motorized string puller. I didn't exactly have a finished concept of the motor, but I actually took a motor from a remote control car that I made in a summer camp a long time ago, and I found it and I dismantled the part of it, and then took this wheel from it and found the batteries. And the wheel didn't exactly work with the strong enough electricity source, and the wires that were soldered onto the wheel or the motor kind of snapping off. So that's what you can see here. I had to actually attach the by using fingertips, using my fingers to actually like have them at the exact right angle to produce the electric current. But I basically used this breadboard and then attached it to it with these cables, and then made it so that at least one of the fingers could come forward on this while spiraling on this wheel. And here's the battery. As you can see in this video, it took a while for me to get the right amount of electricity going through the wires in the right position, but at the end it actually does get around the finger. So yeah, it's pretty cool. Just me showing the wheel working with me pressing against the wires against the little metal receptor bar. So yeah, and that is the end. Thank you everybody who has watched this so much for watching this video and reading this slideshow. I really hope you enjoyed this project as much as I did making it. And yeah, thank you everybody so much for listening to this presentation. My name is Juan Rafael Lenger Caballero, as I said earlier. And yeah, thank you and goodbye.